You have got the book? Okay, so question 3. A beetle swims in the still water of a swimming pool of a constant speed of this, 6 millimeter per second. So that's my V source. The V source is traveling at 6.0 millimeter per second. A swim motion in such, it pops up and down at a constant frequency of this. So that is the actual frequency. The actual frequency is 3.0 hertz, right? Creating a wave pattern, and the diagram shows the wave crest on the thing viewed a certain instant from above. Crests in front of the beetle are 8 millimeter apart. Okay, so 8 millimeter apart, we have a perceived frequency, wavelength, millimeter, and then there's another perceived frequency which is 12 millimeter. Okay, so from the reference point of the beetle, calculate the apparent speed of the wave in front of it. Apparent speed of the wave. Yes, this question is not the best question. The speed of the wave, I'm thinking, well, the speed of wave don't really change, right? Because speed of wave can't change. Only the frequency can change, because perceived frequency is going to be changed. Does that make sense? So is the answer just 3 meter? Do we know the speed of wave? Oh, we don't know the speed of wave, right? So yeah, we can just try to work out the speed of wave. Well, if that is the speed of source, that is the frequency, that is the wavelength. That's the actual frequency. I mean, I can actually calculate the actual wavelength. The actual wavelength is supposed to be half of this value. That should be the actual wavelength, because the thing is moving away. So now, say, if we're creating one like that, if it creates another one, this is supposed to be the wavelength, right? But this thing moved to this side like this. It's creating a 12 over here and an 8 over here. If it created 12 over here and 8 over here, what was like this distance? What was supposed to be over here? So we just add these two together and divide by 2. So you'll get the actual wavelength is supposed to be 10 millimeter.
So is it always you 8 plus 12? Like you add the
wavelength is always add these two together divided by 2. Frequency you can't do that, because frequency is related to speed. There's a relationship in there. But wavelength you can always do that, right? Well, one side you stretch it, the other side if you stretch 2 on this side, you must compress 2 on this side because of the movement, right? So that's why from this we can actually get the actual wavelength. Does it make sense?
But how do we do this? Is 8 millimeters times the frequency to get the speed?
Well, that is not the speed, because that's not the actual speed. Yeah, but if we use this time together, what kind of speed will we actually get?
0.024.
Yeah, but what would that be? What would that speed be though? That is not how fast the wave is moving. I feel like the answer might actually be wrong. Yeah, if we times these two together, but what kind of concept do we actually get? This is the perceived wavelength. But this is not the perceived speed. You can't use the perceived wavelength times original frequency because the frequency has changed. Yeah.
How do you know that it's a perceived wavelength? Yeah.
That's because it's the in front of the wave. It's the wavelength in front over here. Right? I'm actually not too sure what this question is trying to ask us. Okay, so let's say this. Let me just ignore question A, B, C. Let me see what kind of concepts can I get and what kind of things can I actually create by using this information. Okay. Say, first, does this make sense? The actual frequency supposed to be created is going to be 10 millimeter. I mean, that is for sure, right? Say, well, originally if it's 10, and if I move this way to compress this become 8, and then the other side become 12, right? Well, this is definitely for true. So with this, I can actually calculate the speed of the wave, what the speed of wave supposed to be in this medium. Speed of wave will equal to f lambda equals to this times this. 3 times 10 give me 30 millimeter per second. That should be my actual wavelength. Speed of wave. Right?
Yeah.
What's in the textbook?
Is in the textbook.
Yeah.
Yeah, and then if I want to know the frequency in the front, I go the frequency in the front should equal to VW, the actual frequency F, VW minus Vs. Frequency on the back, I'll say this is the back, this is front, equal to F VW, VW plus Vs. Now this is 3, and that's going to be 30, 30 minus 6, 3, 30, 30 plus 6. Okay, and then we can put that in the calculator. Can anyone quickly put this in the calculator, see what is the perceived frequency in the front and on the back?
Yeah. No.
90 divided by 24.
Because they're in meters.
0.05? 3.75? Yeah, what about this one? 2.5? Yeah, that should be the answer. That should be my frequency in the front. This should be a frequency on the back.
Yeah, that's the answer for C.
Yeah, and then if I want to calculate the speed, the actual speed, which is this one, if I use this one with the actual speed of wave with this one, I can actually also calculate. I don't even need to use these two equations. I can use these two information. Say V equals F lambda, and then F equals to V over lambda. So V is 30, and lambda is 8. Put this in the calculator. That should give me the same value. Right? That should equal to 3.75 hertz. Yeah. Does this make sense? Well, I actually don't need to use it because I now know the wave speed. The wave speed will always be the same because speed is dependent on the medium. So that's why in this question here, I feel like they're trying to make it easier for you by asking you a wrong question. Does it make sense? It says from the reference point of the beetle. Oh, it says from the reference point of the beetle. Oh, I know what it means. It means from the reference point of the beetle. It means according to beetle, how fast is the wave going forward?
So we just get 0.08 times 3.
Yeah.
Because it's in front. The wavelength in front is 8 millimeters. So.
Yeah. Yeah, I guess so. But then why would because the beetle is still making a frequency of this, and the wavelength is this. But why would that be the perceived the speed of the according to the beetle. Okay, I'm not too sure what it actually means. We'll have a good think about it. But if we add these two together, we will be able to calculate, well, the perceived frequency over here is going to equal to V over lambda dash. So that becomes 30 divided by 12. That will be give me 2.5.
Yeah, 2.5.
Yeah. Yeah. Hertz over here. So it should match this run over here, right? Okay. So that is how I would do this question. But I just need to have a think. Why does